are going to learn about the most important topics in computer science, that is binary numbers. By the end of this lesson, you will understand what binary is, how it works, why computer use it, and how to convert between decimal and binary. We'll also see how decimal binary is used in real life in text, images, and even music. So sit back, follow along, and let's begin our journey into the world of zeros and ones. Let's start with a simple question. Which number do we humans use every day? It's the decimal system, which has 10 digits as 0 through 9. But computers are different. A computer is made of billions of tiny electronic switches in one of two states, on or off. To represent this, computers are ones for on and zeros for off. This is why binary is. The base 2 number system is the natural language of computers. So remember, binary is not just random ones and zeros. It's the most efficient way for a computer to store and process information. Let's learn how binary numbers actually work. In the decimal system, each place value is a power of 10. For example, in the number 326, the digit 6 means 6 ones, the digit 2 means 2 tens, and the digit 3 means 3 hundreds. In binary, each place value is a power of 2. The rightmost digit is the ones place, then comes the 2s, then 4s, then 8s, then 16s, and so on. Let's take binary numbers 1, 0, 1, 1. Starting from right, the first one is 1, the next digit is 1, 1 times 2, the next digit is 0 times 4, and the leftmost digit is 1 times 8, and add them together. 8 plus 0, 2 plus 1 equals 11 in decimal. So 1011 in binary is 11 in decimal. Let's do one more. What about the binary number 11001? That equals 16 plus 8 plus 0 plus 1, which makes 25 in decimal. Now let's practice counting in binary. In decimal, we count like 0, 1, 2, 3, 4, 5, and so on. In binary, we count like this: 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Let's pause here. Can you guess what comes after 1, 1, 1? Yes, that's 1, 0, 0, 0, which is 8 in decimal. Binary numbers grow quickly in length as we count higher. But remember, every time we move one digit to the left, we are doubling the value of the number. Now let's see how to convert from decimal to binary. Suppose we have the decimal number 13. We divide by 2 repeatedly and record the remainders. 13 divided by 2 is 6, and remainder 1. 6 divided by 2 is 3, remainder 0. 3 divided by 2 is 1, remainder 1. 1 divided by 2 is 0, remainder 1. Now we read the remainders from bottom to top: 1, 1, 0, 1. That's binary 13. Let's try another. Convert the decimal number 22. 22 divided by 2 is equal to 11, remainder 0. 11 divided by 2 is equal to 5, remainder 1. 5 divided by 2 is equal to 2, remainder 1. 2 divided by 2 is equal to 1, remainder 0. 1 divided by 2 is equal to 0 and remainder 1. Reading backwards, we get 1, 1, 0, 1, 0. That's 22 in binary. So far, we have learned how binary represents numbers. But binary is not just about numbers. Computers use binary to represent everything. For example, letters are represented using binary codes like ASCII or Unicode. The letter A is ASCII, is 0, 1, 0, 0, 0, 0, 1 in binary. The letter B is 0, 1, 0, 0, 0, 1. Each character you type on your keyboard is stored as a pattern of zeros and ones. Pictures are stored in binary too. A digital image is made up of tiny dots called pixels. Each pixel color is represented by a binary number. For example, in an 8-bit image, each pixel has a binary value from 000 to 1111, which equals 0 to 255 in decimal. Even sound and music are stored in binary. Sound wave is sampled thousands of times per second, and each sample is stored as a binary number. When computer plays it back, those numbers are turned into sound waves again. So the music you listen to, the movies you watch, the apps you use, all of it is stored as zeros and ones. Let's try a few fun examples to practice binary. What is binary for the number 5? Answer is 101. What is binary for 10? Answer is 1010. And what is the decimal value of binary? 1111. 15. Here's a trick. If a number is all ones like 111 or 1111, its decimal value is always 1 less than a power of 2. For example, 111 in binary is 7 and 1111 is 15. Let's wrap up what we have learned today. Binary is the language of computers. It uses only 2 digits, 0 and 1. Each place value is a power of 2. We can convert numbers between decimal and binary. Computers use binary to represent numbers, letters, images, and even sound. So whatever you see a computer, remember, behind the scenes, it's all just billions of zeros and ones switching on and off at incredible speed. That's it for today's lesson on binary numbers. I hope you enjoyed learning about the secret language of computers. Thank you for watching and see you next time.